Good afternoon, ladies and gentlemen. I will present today two schools, the grammar school in Basweiler and the school center in Titz, both near Aachen in North Rhine-Westphalia. Before we started the renovation of that building of the grammar school in Basweiler, we examined the energy demand of more than 20 municipal buildings for the city council to compare these buildings. At first, we analyzed how much necessary investment costs are necessary to save 1 kilowatt-hour heat energy per square meter per year. For the grammar school, that was only 1.4 euro, and that was very, very cheap because the construction was not renovated since a lot of years. Compared to that, we analyzed the investment cost which were necessary to save 1 euro energy cost per square meter and year. That was, in the case of the grammar school, around 20 euros only, compared to other which were around 80, 100 euros. And so the city council decided to realize that building in passive standard for new buildings. And we decided for a curtain wall, because a curtain wall is much more economic and is also ecological. And we also wanted to avoid changing of the building characters. In my opinion, high quality in aesthetics does not eliminate high quality in energy. We realized the whole school in 5 construction phases. The first construction phase was the administration building, and the last was the gym. The building construction was from 1971. This school was more than 14 years old when we started the design for that project. We did not only optimize the energy efficiency of the building's surface, we also modernized the school in total. We implemented a self-teaching room, new rooms for the teacher, new sanitary rooms, and so on. And we made the building barrier-free for people with disabled peoples. It was a very ambitious project because the government of North Rhine-Westphalia promised a state grant, a huge state grant, in the case of reaching passive house standard, which was certified because we designed a facade as a curtain wall from different plates, different sizes of plates, of high pressure laminate. High pressure laminate is recycled paper. That's sustainable. In my opinion, it's also ecologic. And we had to organize and to handle very complicated thermal bridges. Because of that very, very ambitious goal, they promised the grant. And the aim was reached, and so they got a grant of around 4.8 million euros from the government of North Rhine-Westphalia. It was the best project in a competition. On the north, we reduced the window areas by 90%. On the south, we extended the window areas to gain sun energy and to gain some radiation. The investment cost for the total project were around 10 million euros. For that building in normal standard by law at that time would have been 9.6 million euros, only 400,000 euros less. And so, in the case of the state grant, the client's equity ratio was only 5.2 million euros. It was a very good business for the city of Basweiler. In the case of existing buildings, it's not so easy to ensure the surface's airtightness. Because of that, we decided to do it from the outside. Our outside envelope was the airtight surface. We had to work neat and tidy. In the case of passive house, it's always very important to work neat and tidy. Though a passive house is not a high-tech building, it's a low-tech building, but we had to motivate and to sensitize the crafts to work very carefully to pass the blower door at the end and to have a good result for the blower door test. Here we can see the bearing construction of the curtain wall. We decided for stainless steel anchors because stainless steel is a lower heat and warmness conductivity compared to normal steel. We had to use suitable airtight foil because of a sustainable building. It should work for a long time. Such pictures are witnesses for carefully neat and tidy work. Here, the ventilated facade of the building. The thermal insulation should also protect it against water and against rain. Because of that, we covered the thermal insulation with bituminous sheetings. Also, this slide is a witness of very carefully neat and tidy work. It's obligate to minimize thermal bridging, to minimize the thermal bridges also for the bearing construction. So we installed thermal separating materials, and in the picture on the left you can see it. It was always necessary to cover leakages of the concrete construction. It was necessary to install 3 layers of thermal insulation. Here you can see how clean and how carefully the crafts did that work. And we used, it was self-evident, of course, we used thermal bridge-free anchors for the facade. The exterior airtight was the envelope, the airtight envelope. In that case here, we used 2 layers of thermal insulation. The thermal insulation is covered with a material which is water resistant, but it's also open for vaporization. In some parts we had to save back the ceilings because of thermal bridges had to avoid in these parts we filled in thermal insulation, and so we could organize minimizing thermal bridges. For the supporting structure, we used also stainless steel materials. The ceiling were covered with thermal insulation too, and the walls were appendixed with 50 centimeters of the basement walls to minimize thermal losses. In the classrooms, we installed open ventilation pipes so we could make sure that the teachers made experience in rooms of a passive house, and they always saw and they always can make the experience, also the pupils, that they are educated in a passive house. But in the case of open pipes, we had to use double walled pipes, and also we used, that's obligate in ventilation pipes, to use materials which has sound absorbing possibilities. Above we see the classroom, one of the classrooms before the building construction, and here after the building construction. Because of extending the window areas, you can see the structure, the bearing structure, the piers, also from the outside. But it's a very nice character of the aesthetics of the buildings. On the north facade, we reduced the window areas by around 90%. The result of the PHPP was 14 kilowatt hours for heat demand for the building section 3 and 4. It was around 15, between 12 and 15 for the other building sections. Here is the auditorium. The auditorium was extended so we could gain a canteen also. The auditorium can also be used as a canteen now. The gym was a problem because the cavity floor was installed only 2 years ago, and so it was not, it doesn't make sense. It did not make sense to rebuild that floor for thermal insulation. So we could not insulate it, and so it was very ambitious to bring it to passive house standard, which was certified, but the goal was reached. The energy demand of the gym is exactly 15 kilowatt hours per square meter per year. This slide shows the difference between the facade before the building construction was started and afterwards. Here we can realize the different sizes of panels of the facade and different green colors, and so we can change sometimes if necessary without changing the character, and it looks always new, and it makes no difference after changing one plate if necessary. This slide is self-explanatory. The next two, that's the auditorium and the canteen, before and afterwards. The energy saving after retrofit to passive standard was calculated by 93.2%, and the measured value was better than the calculated value. In 2010, we finished the first construction phase, and with that building, the city council participated in a German competition and won that competition with a prize money of 40,000 euros. What about the CO2 concentration in classrooms? The country Bavaria in Germany made a measurement some years ago to analyze the CO2 concentration in classrooms. In the case of more than 50%, the CO2 concentration was more than 1,600. Only less than 17% were less than 1,000 ppm. That's the value we wish in Germany. In the case of the grammar school in Basweiler, we made a monitoring, and the result was in average around 400 ppm for CO2 concentration. In one case, there were 800 ppm, 200 less than the optimal value by law. That was due to the double occupancy of the classroom, because we made the building construction during operation. So sometimes it was necessary that the double number of pupils were taught. The school center Titz was also a very ambitious project. The mayor of the city of Basweiler recommended his colleagues to commission us for their school renovation. And so we were commissioned. That was during the building construction. And in that school, we decided for renewable materials. Wooden is regrowing, so we decided for huge parts of the facade to use wooden materials. And the city council wanted to use the logo colors of the city of Titz for the school. And we did. Here you see orange, yellow, green. So they were happy that we reached a passive house in a high quality of aesthetics, and also by using the logo colors of the city of Titz. Here we can see the wooden materials and also the logo colors for the balconies. In my opinion, it's also, I imagine that's very, very important to supply the rooms and also the corridors with daylight, with enough of daylight. Because of that, we designed inner courtyards to supply the corridors with daylight. This small picture gives us an expression of the canteen of that school, and also here an expression of the interior of the gym with the keyed cavity bottom, which we did not change. And that's the facade of one of 3 gyms of that school center. Let me finish my presentation with one slides which explain or which are witness of my topic of the topic of my presentation. In schools, energy efficient is not only what we should reach, but pacifers with low CO2 concentration, with permanent fresh air supply and so on. That's, in my opinion, efficiency in more dimensions. That's necessary for schools. And I will finish with a Swedish wisdom that is a child has 3 teachers. The first teacher are the other children. The second teacher is the teacher himself. And the third teacher is the classroom. Muchas gracias.